We are given a little diagram of a circuit, and we are told that all three resistors have the same resistance. So these zigzags are going to be our three resistors, and then we have three ranking questions that we have to complete. So the first question is asking us to rank the current of each of the following points and in descending order. So the current in a series circuit. So this is a series circuit because they're all in a series and they're not connected in a parallel fashion. So it's important to remember that the current in a series circuit is the same for every resistor. So the current at any point is equal to the current at any other point, and it just keeps going like that. I at point 1 is equal to I at point 2, etc. So all of these points that they have given us, each point is going to have the same current. The same current is going to be running through the entire circuit. So if we want to rank this in descending order, it's just going to be 1 for all of them. The second question is asking us to rank the voltage difference at the following points in descending order. Voltage is dependent on current and resistance, and we already know that the current is going to be the same throughout the entire circuit, so we are just going to be basing these values off of the resistance. So even though the current is the same throughout the entire circuit, the resistance is not. The resistance changes at different parts, and we can see that here, like for example in this stretch there is no resistor, and in this stretch there is no resistor, but if the current starts from this positive side, if the voltage starts from this positive side, this side is going to have least amount of resistance because there's no resistor at this stretch up until point D, and then that's when the first resistor comes, second resistor, third resistor. So after all of these resistors, the voltage is obviously going to be a little less than it started before at this positive end. So it goes out really strong, weakens at each resistor, and then a low amount of voltage reaches the end. So in descending order, we're going to start with the stretch that has the biggest voltage difference, and that is going to be this stretch from point F to point B, because this is not only including all of this stretch that has no resistor, but it's also including 2 of the resistors, and that is out of all of these by far the biggest stretch that they're asking us to look at. So in terms of voltage difference, this the voltage from point F to point B has the largest amount. So next we are going to look at these stretches of the individual resistors. And so we know that the potential is based on the current and the resistance. So we already said that this stretch is going to have the least resistance, and then these parts are going to have some resistance. And note that they told us in the problem that all 3 resistors have the same resistance. So if we have the same resistance and the same current flowing through all 3 of these, that means the voltage in all 3 of these is going to be the same. So if we're going to rank it in descending order, the second highest amount of voltage will be in all 3 of these resistors. So voltage from point D to C, voltage from point C to B, and voltage from point B to A is all going to be the same. And that leaves us with the voltage from point A to E, and this is the stretch that is at the very end of all 3 of the resistors, so it's going to have the least amount of voltage. And if you are using the same homework program as I am using, we are going to rank this as a 5, because if we have 3 numbers in a continuous tie, we are going to skip that amount of rank number, if you could say. So since we have 5 objects, the least ranked object is going to have a rank of 5. Finally, they are asking us to rank the actual value of the electric potential in descending order for the following points. So this one is a little tricky because it's kind of asking the same thing as the last question was asking, because voltage difference and electric potential difference, they are the same thing, but in this one they've just given us individual points, while in the last one they gave us stretches to rank. So we are going to apply the same idea that this stretch, so any point in this stretch is going to have the least resistance and therefore the highest voltage and the highest potential, and this stretch is going to have the most resistance and least voltage and least electric potential. So the 2 points in this stretch that they have listed here, F and D, they both have the least resistance because they come right after the initial voltage input and before any resistor comes in. So they have the highest actual electrical potential. So we're going to rank them both as 1. And so since we have two numbers tying at first place, the next rank number that we're going to give is third place. And third place goes to point C because it is after the first resistor. Point C comes after just one resistor, while point B comes after 2 resistors, so it's going to have less electric potential. And then point A comes after all 3 of these, so it's going to have even less electric potential. So point C is in third place because we're skipping second place. And then point E and A, which is what we have left here, they've skipped B, but E and A, they're in the same stretch, there's no resistor in between them, and they both have the least amount of electric potential and voltage difference, so they're both going to tie at fourth place.